Howdy guys, Jimmy Song here. Welcome to another episode of Bitcoin Tech Talk Q&A, and we are going to go over a lot of the events of the past week and a lot of the interesting technical developments. This is based off of the newsletter that I send out, Bitcoin Tech Talk, which comes out every Monday. I've done 120 issues so far, and you know, every Monday I go over the stories and go over what they mean. I'll also take some questions from the audience and figure out if there's any like additional videos that I need to make and so on. Anyway, let's get straight to the stories. We had a bunch of stuff happen in this past week, so let us take a look at some of those stories. All right, so here is the Bitcoin Tech Talk newsletter, and of course, today is January 21st, 2019, and there's a bunch of stories that I included. There are 8 in particular. Let's take a look at them and go over what they are all about. All right, so of course I get that. All right, so first one is, what is Bitcoin? This is an article I wrote for Hacker Noon. I felt like I do a lot of explaining of more advanced technical concepts, but oftentimes like the thing that a lot of people actually need is something that explains the basics. And in this one, I've sort of adapted from a talk that I have about what Bitcoin actually is, and really it's going over what scarcity is and how you can create scarcity. There's 2 types of scarcity. There's centralized and decentralized. And I basically make the argument that decentralized scarcity ends up being money oftentimes. And in the digital realm, we didn't really know that it was even possible until Bitcoin came along. And when Bitcoin came in 2008, decentralized digital scarcity came into the world, and it's a really significant invention for that reason. I'm going to have a part 2 that goes over all of the different properties that Bitcoin has as money, a lot of the desirable traits that you might want, and just sort of comparing it to a lot of different decentralized monies that existed before, and go over how that would work. So that's another that's an article that you should look forward to. I'm intending this article to be something that you can send to someone that doesn't know anything about it, and you can go, okay, well, here's what it is. And then if you're still interested, ask me more about it, and so on. So that's the point. I like Hacker Noon. They have a lot of articles, but they have had some articles on a lot of crappy coins recently. So that's why it led me to write this one. All right, let's take a look at this one. This is proof of stake Bitcoin sidechain. So I've crapped on proof of stake quite a bit, and it really doesn't make sense oftentimes because it is just sort of signing something, and the people that have the money get to make more of it, and there's no real security behind it other than their signature, and of course, you have to have like some mechanism for figuring out who's allowed to sign and so on. And it's usually done proportionately to how much you're staking and done somewhat at random and things like that. So a lot of misaligned incentives when you use proof of stake to create new coins. But for something like sidechains, there is something, there's room there for something to work. Because in a sidechain, you're not creating any coins. You are really just using it as fees. Now, like the Drive Chains protocol has, has some form of merge mining, which gives the miners of Bitcoin a lot of the fees that are in order to process anything in a sidechain. A proof of stake Bitcoin sidechain might have some use in some limited way. As long as you trust the people that are on that sidechain, it might be useful. And there might be certain cases where you do know the other participants in that sidechain, where it's all known, it's not anonymous like it is in Bitcoin, where anyone can come in and out, where this might be useful. So it's an interesting idea. There's a there's a design document that we can take a look at, proof of stake, Bitcoin sidechains. There's, like the actual opcode to go in and out and things like that. There's a whole bunch of interesting mechanisms to make it work. But I encourage you guys to take a look. It was on the Bitcoin Devs mailing list. If you're not subscribed to that and you are interested, I highly encourage you. All right, next one is new draft Sphinx send mode for spontaneous payments. So this is by Roast Beef, or a lot of people know him as Lalu. He's the lead developer at Lightning Labs, and he's been working obviously on Lightning for quite a while. One of the more annoying things about Lightning right now is that you can't just sort of send to a node, right, on the a node on the Lightning network. You have to get a payment request first, or what you call an invoice, and then given an invoice, then you can pay it, right? So it requires some interactivity. So you can't just have like a donation address, for example. It makes it very difficult to do that. So this is a pull request to make invoiceless payments. So that should allow, in theory, some sort of like direct payment to a donation address, for example. And that's something that we've had on layer 1. It's coming to layer 2 as part of this PR. And it's an interesting development. And if you haven't played with Lightning, there are sort of significant differences between layer 1 and layer 2. And this is one of them. It's that you have to be online to receive the payment, and you have to tell them where to send it and how much to send and so on. And that's what a payment request does. So anyway, it's something. It's an interesting idea. You should definitely take a look. And if you can read code, it's in Go. It's based on it's in LND, and honestly, I find Go to be really, really readable, and especially like LND is just really well commented. Like right here, look at that. Extra onion blob returns any parsed EOB data. If any data is present, then type field will be anything other than Sphinx. Like it's well commented. Like sort of about the edge cases because they're always like in there. It's usually well tested. I mean, it's just a pleasant, like, look at the additional tests that are written here and things like that. It's just pleasant to read if you don't like reading maybe some of these other languages. Anyway, please take a look if you are interested in Lightning and invoiceless payments. All right, here's another one: routing fees under custodial conditions. All right, so this is by anonymous developer ZMNSCPXJ. Nobody knows who this guy is, but this developer actually contributes quite a bit, and whenever this person says something, you really should read it, especially on the Lightning Dev mailing list. Anyway, there's a particular routing fee issue where you might have something not balanced quite right, and this was brought up in another one, mandatory D or H UX issues, and this is in relation to the user experience around a particular type of transaction. So like these are the things that the Lightning devs are thinking about. Always good to like check in and see what's going on and see if you can contribute, right? Like if you can understand them. All right, so here is another one, Fundamentals of Proof of Work by David Vorik. Very good guy, David Vorik. He works on SIA, and he does he knows a lot about mining. This guy I think was working on getting or making some hardware and things like that. Anyway, he wrote an article a while back arguing that like there's this large room between FPGAs and ASICs that if you have some sort of like adaptive proof of work or something like that, that there's plenty of room to add or plenty of room in technology to make that work, right? Like to make something between an FPGA and an ASIC that would be able to adapt as the proof of work adapts. Anyway, this article in particular is about 51% attacks, and he starts with a really bold declaration here. 2019 is the year of the 51% attack. We already had one with Ethereum Classic a couple of weeks ago, but there's a lot of data that he brings forward that is honestly really pretty compelling. So first, he goes through what's changed since 2017. There's a lot more professionalism in the industry. There's a lot more people with a lot of equipment. And in particular, there's hash rate marketplaces where you can go and rent out hash rate for a particular coin, and in particular, GPUs. And he goes on to talk about large mining farms, which have 10,000 GPUs in a single farm, and oftentimes over 100,000 GPUs, and the largest has over 500,000 GPUs. So if your coin does not have more than 500,000 GPUs worth of hash rate on it, that means your coin is vulnerable to that miner. And the thing is, the people that the 51% attack hurts are the exchanges that are listing it, and that provides liquidity, that provides like a lot of buzz about your coin and so on. So losing that is absolutely critical to a lot of these coins. I mean, like if your Bitcoin and like somebody one exchange gets screwed or something, or they behave badly, that's happened before, right? Like but there's a lot of exchanges with Bitcoin on it, so it's not that big a deal. But if you are coin number 57 on CoinMarketCap and you're trying to get listed on Binance or something, and basically this 51% attack happens, well, Binance might just drop your coin because it's not worth it. Like whatever money that they've made in profit off of the fees in trading on that coin might be lower than whatever they just lost in customer funds, right? Like in which case they're usually inclined to make them whole. So at that point, they might just drop the coin and say, you know what, it's not worth it. Like and the thing is, with a 51% attack with this much GPU power or this much hashing power, you have the ability to really like go deep into it, right? Like you can have 1,000 block reorgs. The exchange can keep like increasing the number of confirmations necessary. They'll just do a longer and longer attack, and it takes longer to actually get that money out. But it becomes more and more of a problem. So the exchange has a couple of options. They can do more AML, KYC, and try to prosecute those people. But that way lies like a lot of trickiness, because the kinds of people that can do this will have bank accounts and things like that, and we'll be able to get it out of Macau or whatever. There's a really interesting YouTube video, by the way, about how the SWIFT system was hacked, and some North Korean operatives got out like $20 million off of some Indonesian bank or central bank or something like that. There are ways out of the system, so you have to be really, really careful with that. So if the exchanges start dropping some of these 51% attack coins, then, well, I mean, that might be the end of a lot of these coins, because once like if this keeps, it's one thing to happen like once, right? Like, but if it keeps happening, then an exchange really has no choice other than to drop it, or I mean, like, or require like 2 million confirmations or something like that, like something where you need to keep it with them for 6 months before you're able to trade it. In which case, they're not going to get many trading fees. So it becomes like sort of like positive versus negative. Like if you're not going to earn that much revenue off this coin, then is it really worth it? Like all the incentives are such that as these coins get more and more attacked, exchanges are more and more incentivized to drop them, in which case, it becomes kind of a crazy thing. All right. So anyway, that was really interesting article, very, very well written, and really compelling data in here, and like I said, David knows quite a bit about mining, and the game theory here is absolutely spot on. So I encourage you to read it. All right, here is another article, Why Ethereum Architecture is Flawed. This is by Hugo, very, very good writer, written a lot about proof of stake and so on. But, essentially, he goes through a lot of the controversy, and really it's engineering soundness, right? Like there's something wrong with Ethereum, period. And it's not that good a tech, right? Like it's built on, as they say, like toothpicks and bubblegum. It's not really like, heavy duty engineering. And this is a lot of the impetus behind Ethereum 2.0. If you don't know what that is, they have a whole separate Ethereum that's sort of built from the ground up again. And what they're hoping to do is transfer everybody from Ethereum to Ethereum 2.0 eventually, and then say, oh, this is, like our new thing. Yeah, that totally does not, that totally sounds so decentralized, right? Like, yeah, everyone has to switch over coins to something completely different. Yeah, I mean, it's gonna be the mother of all hard forks when it comes to that eventually. But yeah, there's a lot of really good information in here, and there's some notes down here that for further reading. Explain verification, not computation, and Bob McElrath also did that. So yeah, I like, and this is something that I've talked about for a while. Like, Ethereum was sort of built by, shall we say, people that weren't that experienced in software engineering. I mean, you got to think about like how old Vitalik was when he thought of it. He was 19 years old. And, I mean, there are decent 19-year-old coders, but you don't really know the art of software engineering at that point. I certainly didn't at that age, and I doubt many people did. People sort of worship him as a wonderkind or something like that, and think he's like all brilliant and stuff. But you look at the actual technical choices that he's made, and it looks exactly like what a new grad out of school would make. And it's kind of sad, but I mean, he is a smart guy, but like the technical choices that were made in Ethereum were honestly kind of terrible. And this article goes through all of that. So encourage you to read that. Let's also talk about this reentry attack. This is what delayed the hard fork last week of Constantinople. And this post goes into detail on what a reentry attack is and why it is really, really bad. So among other things, you're supposed to be able to enter a smart contract like for once, but apparently there's a way to get into it again, given the Constantinople code. And that was scary enough that they delayed the hard fork for at least 6 weeks. Who knows how long that will be? But there's a the source code is here, and you can look at like exactly, good on them for at least doing a security audit and not having people lose money. But still, it's this is a pretty bad bug, guys. Like like you can lose a lot of money, or there was potential to lose a ton of money using this. So yeah, like these are the details of the reentry attack. It's more or less getting into a smart contract more times than you're supposed to, and you might be able to transfer more money out than you're supposed to, and so on. But yeah, that's what that article is about. Encourage you guys to read it. Lastly, here is BitMEX's. They do some great research on there, and they come up with some great visuals and stats and tables and stuff like that. I always love reading their stuff. Tracking $24 billion worth of tokens ICO makers allocated to themselves. So, I've always been against pre-mines, and Vitalik, I think, said in a tweet a while back, I'm proud of the fact that I've normalized pre-mines. And this is basically the normalization of printing your own money, or allocating a bunch of money to yourself without having built or proven much at all. And they're keeping track of this money, right? And that's what this article is about. I don't think it's a good thing. I think it's morally wrong to do that. I think it should be at the very least locked up until you've delivered what you said you would deliver. Vast majority of the time, it's it's on some schedule and you get it no matter what. I think a couple of teams have done, we have to meet this milestone, but like the adjudication on that is like, who knows if they actually completed it, or they can be in cahoots with the people that are deciding whether or not they complete it. So it comes with its own set of problems. But anyway, some really interesting stuff. So value of ICO token coins allocated to token teams, it's 21.5 billion. Issuance of two teams post ICO, 2.7 billion. So apparently it wasn't enough to pre-mine. They had to allocate even more coins to themselves afterwards. And there's enough projects that did that it shows up significantly on the balance sheet. Coins leaving team address cluster, this is probably sales. So there's probably a 1.5 billion of that. Profit loss due to token price changes, 12 billion. So yeah, that's happened because there's been so much money lost in the ICO realm or in altcoins and so on. That's a significant amount. Net impact of NOAA, that's a token burn, and net impact of EOS, I guess they did something, and that caused 1.2. So really, current team holdings, $5 billion. 5 billion, of which they have cashed in about 1.5. Is it still going to remain 5 billion? Very hard to say because token prices fluctuate. And if it continues to go down, I expect that number to be very, very tiny. And of course, the liquidity on these things is very, very tiny. So the liquidation value is probably significantly less than 5 billion. If you try to liquidate a significant chunk of a coin that has very little liquidity, you're going to crash the price. And you're obviously not going to get very much. So I imagine it's probably more on the order of like 1.5 billion that they have. But who knows? We'll see. Anyway, summary data, value of coins issued, and so on. And they talk later about exactly what happened to Noah Coin and all of these other ones. Oftentimes they raised a ton of money. 5.4 billion in Ethereum, which is like kind of a crazy sick number. Imagine if people just like invested in Bitcoin instead. It boggles the mind. Anyway, there's a lot of interesting data in this, and I totally hope that you guys read this and think about where the space is going with respect to that. Anyway, as always, you can subscribe to Bitcoin Tech Talk in the show notes. There's a link directly to signing up for it. Let's see if there are any questions. Let's see. I'm not going to answer questions about NEO. How does mining reward work in a POS sidechain? New coins can't be created. No, but everyone does have to pay fees. And if they pay fees, then those can go towards the proof of stake people or whoever is willing to stake it or something like that. You can't create new coins, but you can always distribute the fees and so on. And that might be low enough that like locking up your capital, if the market sets that rate, then locking up your capital for that long should be roughly the interest rate of however long, maybe slightly above the normal interest rate that you could get with that money, but get with a little more variance, something like that. What happens? All right. What happens when you open a channel with a remote balance? I mean, when you open a channel, it's usually like you both have a balance on either side of it. So I don't think that question makes sense. What do you think of Luke Dash Jr. saying, "Don't use SegWit"? I think I understand where Luke's coming from because he believes that blocks that are too large make it really hard for full nodes to verify, especially on lower grade hardware. And his argument has always been, SegWit is a block size increase, and therefore it causes a larger block size. And right now we have 1.2, 1.3 megabyte blocks. If you don't use SegWit, then the blocks would essentially be smaller, make it easier to verify, and so on. So what he's advocating for is smaller blocks so people can be more participatory on the network, I believe. Do I agree with him? Not really. No, I think it's fine to expect full nodes to be able to verify. I mean, there might be some pathological cases that I haven't thought of. And I mean, Luke thinks about this stuff deeply, guys. So like, dismiss his opinion at your peril because he does have very good reasons for why he thinks these things. Do I necessarily agree with him? No. But like he's one of those people that like has thought about all of this stuff at a very deep level. So if you're going to come at him with an argument, he's probably thought about it, and he has good reasons for why you're wrong. So that's his opinion, and he has good reasons for it, and I respect it. But you don't necessarily have to agree with him either. All right, let's see. What other stuff? We call him Z-Man. Oh, I should stop sharing so you guys can see me. All right, sorry about that. Can't someone just break Ethereum so it will be finally death? Well, here's something that I've been thinking a lot about, which is that, when you quote unquote, break something, oftentimes it's not that many people that are affected, right? Like if it affected every holder, right? Like something like inflation would definitely affect every holder. But if it doesn't affect everyone, kind of like the Ethereum Classic 51% attack, it affected an exchange, but that's really a couple of exchanges that lost a bunch of money, but that's about it, right? Like they lost their money. They didn't require enough confirmations, or they listed a coin that was very vulnerable to a 51% attack. Does it really break anything? I mean, like Ethereum Classic actually didn't drop that much afterwards. A lot of people weren't concerned because they were like, "Well, it didn't happen to me. I'm not that exchange. I have my own keys, right?" Like, I'm sure you would feel differently if you were the exchange, but unless you're on the receiving end of a double spend, I mean, do you really care? And I wonder about that. And part of me thinks that if you had a 51% attack on something like Bitcoin, might not drop the price quite as much as you think. In fact, it might prove Bitcoin's anti-fragility. A lot of people might be like, well, okay, more confirmations, like I want like 12 confirmations instead of 2. And exchanges might require that and so on. That might hurt their trading volume and so on. But who knows, right? Like so for bigger coins, that's the case. I mean, we talked about the smaller coins which only have like 1 or 2 exchanges. But yeah, I mean that's it's just something to think about. A lot of these things where you quote unquote can break a coin, and Ethereum's had plenty of those, right? Like DAO hack, parity bug, lots of other things. They're hard forking constantly, but it continues to have value because for a lot of the holders of Ethereum, they don't really care, right? Like, well, they got bailed out on the DAO, and that was like a sixth of the entire ecosystem. So I think that's probably why they got bailed out. But if it doesn't affect that many people, then they might just be like, okay, well, that's fine. It's just sort of as long as it didn't happen to me, kind of attitude. All right. Let's see what other stuff. What do you think about all the pumps? I mean, I think most of them are pretty bad. All right. I have Bitcoin. I haven't moved in a long time. What is the best way to move them without combining all of the UTXOs? Do them one at a time. I mean, that's exactly what I would do. Yeah, I mean, you can do one for one UTXOs to an address on a HD wallet or something like that. It's annoying, but definitely possible. You can also go through something like Wasabi and move them all in like move them one at a time into Wasabi and then like use CoinJoin or something. Beam or Grin? If you had to pick one, Jimmy, probably Grin. Beam had a pre-mine and they're stalled as of a certain block number, so I would say Grin. But I mean, neither, to be honest. What is your reasoning for deciding on a block size? Well, you would have to calculate, the CPU bandwidth and storage needed to safely, validate them in a reasonable amount of time. That's probably the metric that Luke was looking at. All right. Do you also think it is early to write a book about the Lightning Network? Absolutely, and one of the reasons is because of SegWit version 2. It's coming up very, very soon. SegWit version 2 is well, I mean, not very, very soon, but sometime this year it will probably become formalized, and people will start working on it. There might be code review pretty soon after that. But that's going to change the Lightning Network semantics quite a bit. So any sort of funding transaction, payment channel transaction, like the op mass stuff, all of that will change how it works. So the nuts and bolts will be upgraded as part of SegWit version 2, especially with Schnorr signatures. That takes it to another level. So there's a lot that needs to be worked out, and this is why we call it sort of beta level software, because it does work great with the current system, but it'll be a lot less taxing on chain, and it'll be a lot less data going back and forth, and it'll be more secure and things like that. If once Schnorr and things like that go in, because you'll have the ability to do multi-sig or using musig and have nobody on chain or on Lightning know about it. So really cool stuff. Yeah, so I would say Lightning Network book is probably a couple years away at least. Although, I mean, I suppose someone could write something on the current state and just have to upgrade the book, in a couple of years when Schnorr or SegWit version 1 is out. Anyway, yeah, that's about it. I have some other videos coming out this week. One about the controversy around Neutrino and SPV in general. Another one around, well, I forget exactly which ones I made yesterday, but anyway, they're going to come out this week. So hopefully you guys will watch those. Thank you guys for joining me. This song is